Welcome to Study Loop.
Let's start by first finding what will be the vertical height through which the skier or through the person will fall at the point where they lose contact. So we know that this is a circular path, so this would be r, which gives me that this would be r cosine of theta, and then this would be r minus r cosine of theta, or I can write that as r, and then within parentheses 1 minus cosine of theta. So this is going to be the vertical height through which the person will drop when they lose contact. Then we make a free body diagram. So at this point we know that we have the weight of the person, mg, we're acting vertically down, and we also have a normal force, Fn. But then this mg needs to be resolved into components. So let's say that the component of mg, which is parallel to the radius, that would be mg cosine of theta. And why do I say that is because if this angle is theta, then this angle here will also be theta. And then the component which is tangent to the surface, that would be mg sine of theta. So we have our free body diagram. And now when I look at the free body diagram, the component of weight that's pointing towards the center is mg cosine of theta. So mg cosine of theta minus Fn, that should equal the centripetal force because the person is moving in a circular path. And then at the point where they just lose contact, Fn will be equal to 0. So I can actually rearrange this equation a little bit. I can pull that r over to this side. I can say r mg cosine of theta is equal to mv squared. And then I can divide both sides by 2, and what that gives me, it gives me the kinetic energy of the person at the moment that they are about to lose contact. And now we can go back to our law of conservation of energy, which says that the kinetic energy initial plus potential energy initial is equal to kinetic energy final plus potential energy final. Now the initial kinetic energy is 0 because the person started from rest, and the initial potential energy is mgh, where h we just found was equal to r times 1 minus cosine of theta, and the kinetic energy final we just figured 1/2 mv squared, which is equal to r mg cosine of theta over 2. We can take the final potential energy to be equal to 0 because that's the lowest point in our consideration. So to rewrite this equation, we have mg times r times 1 minus cosine of theta is equal to r times mg cosine of theta over 2. We can get rid of mg and r, divide both sides by mg and r. So we have 1 minus cosine of theta is equal to cosine of theta over 2. Simplifying that gives me cosine of theta is equal to 2 over 3, and that gives me theta is equal to 48.2 degrees. So the answer to the question would be theta is 48.2 degrees.